Okay, let's find out when a particle reaches a minimum speed if its path is given by r of t equals the vector valued function with components 3t squared, 2t, and 4t squared minus t, where t is in seconds and distance is measured in centimeters, although I don't think the distance is going to matter much because we just want to find out when the particle reaches a minimum. So we just need the t value that produces the minimum speed. So what's the speed? The speed is defined to be the magnitude of v of t, the velocity vector, which is, of course, the magnitude of r prime of t. So let's start by finding the function in terms of t that we want to minimize. Okay, well, v of t is obtained by just taking the derivative of each component. So that's going to be 6t squared. That'll be the first component of the velocity vector, the derivative of 3t squared. And then derivative of 2t is 2. Derivative of 4t squared minus t is 8t minus 1. So there's your velocity vector. And then, of course, speed is the magnitude of that. So let's take a big square root here and sum the squares of the components of v of t. So the square of 6t squared is 36t squared. Square this guy, you get 4, so add in 4. And then square the 8t minus 1 as a quantity. So let's simplify a little bit. I'll start with expanding 8t minus 1. Quantity squared, that'll be 64t squared minus 16t plus 1. And then if we combine like terms, we'll get the square root of 100t squared minus 16t plus 5. So that's it. That's the speed right there. That's the speed. So what t value produces a minimum here? Well, I'll tell you what. The t value that makes this square root function a minimum will be the same t value that makes this function, I'll call it f of t, a minimum. 100t squared minus 16t plus 5. What did I do to get this? I squared the speed function, which deletes the square root. So that should hopefully make sense to you. The t value that makes f of t a minimum will be the same t value that makes the square root of f of t a minimum. Okay, so what is this thing? Well, it's a function of one variable. You could use calculus 1 techniques to minimize this function. In other words, you could take the derivative, set it equal to 0 to find the critical value. There'll be only one, and that will turn out to correspond to a minimum if you do the first derivative test on it. However, since this thing is a parabola, it graphs to look like this. I know it's a parabola opening up because the term, the coefficient in front of the t squared is positive. So the minimum value, the first coordinate of the minimum value is the first coordinate of the vertex. It's the t value. Then whatever the second coordinate is, it doesn't really matter because it's not really the minimum we're interested in anyway. The t value, though, that produces the first coordinate of the vertex will be the one we're interested in because the vertex occurs at the minimum. So how do we find the first coordinate of the vertex? Well, you may or may not remember this formula. So I'll call this the t minimum value, t subscript min, just to give it a name. You may remember this formula, negative b over 2a for the first coordinate of the vertex of a parabola. And that's where, in this case, a is 100 and b is negative 16. So that becomes 16 over 2 times 100, or 200, which is 2/25. So the minimum t value, or the value of t that produces the minimum speed value is 2/25 of a second.